Okay, good morning, all of you. I'm audible now, Rahul.
Yes, sir. Audible, sir.
Okay. We see today's class. We have there is a second semester another subject I'm going to take in that evolutionary algorithms applications in power engineering. So this is the subject. In this, we'll deal with only optimization algorithms are also called as evolutionary algorithms that in terms of the power engineering applications. So what we are going to discuss some of the units in the algorithms. After that, we need to apply that algorithms into the power system applications. In that first unit, fundamentals of soft computing techniques. So here we'll see the basics, conventional methods, and then evolutionary algorithms and comparison between these two, and some constraints and with constraints, without constraints. All basics we are going to deal in this unit. And after that, one by one unit, will explain initially as per the syllabus what are the topics we are going to cover. After that, we'll move on to the fundamentals of techniques. So here you can see the course evolutionary algorithms applications in power engineering, and I'm going to deal this. And there is a title of units. Fundamentals of soft computing techniques is the unit one, and another unit genetic algorithm, that is the one of the technique to solve the problems or optimization is nothing but here is a function they will give. You need to optimize that function, or we call it as a minimization problem or a maximization problem, like that. And the modified particles form optimization and some basics of PSO. It may be known in the UG level and all, or anyhow we are going to review of the PSO algorithms. After that, we'll go for different modifications in particle spam optimization. And after that, differential evaluation. This is the another technique. All these things are evaluational algorithm or heuristic, meta heuristic techniques. And the last unit, applications of power systems. These are the topics we are going to cover in this course. So one unit is a fundamental, or you can say that computation techniques. Another one is second unit to fourth unit. These three units are going to discuss three algorithms. One is ZA, another one is PSO, and third one is the DE. By make use of these algorithms, we are going to apply these algorithms to power systems. It may be any problem, economic load dispatch or optimization, or maybe test function minimization, or maybe load frequency control, or single area, or multi area. So all these things we are going to apply using this algorithm. So that's what we are going to do here. And now some books, a lot of books are available in library also, or in online, some more Google books also there. First one is recent advances in spam intelligence and evolutionary computation. And another one is multi-objective optimization using evolutionary algorithm. Another one is modern heuristic optimization techniques, theory and applications to power system power systems. These are the three books, and many more books are already given in the syllabus copy, as well as you can refer library also. Some more books are there to cover this. And now in this first unit, that is the fundamentals of soft computing techniques. We have classifications of optimization problems. That is the topic. In that, unconstrained and constrained optimization means some problem without subjected to the constraint. Simply, you are going to minimize one thing. Like, you want to go to some city, let it be from Hyderabad to Delhi. That is our objective. So without any constraint, then you want to travel, it may be getting as a, minimum cost, one aspect. But we are not considering time. There is no rule you have to go by bike or car or flight or train or something. These are the constraints. If the thing is there, you may go by something cheaper transportation, and it may take longer time, but still your objective is to minimize the cost of travel. Then it may be one cost you will get, or there is a lot of constraint. You want to reach Hyderabad to Delhi with lesser time. Let assume that only within a day or maybe within a 2 hours or 3 hours duration. In that case, the constraints are there. Then you have to choose, or you have to satisfy that constraints. To meet that constraint, you are going by flight, then the cost will be high still. So these are the parameters with constraint and without constraint. Or you want to buy a car, then your object is to buy a car with less price. In that case, you may select low-end vehicle or something. The cost may be minimum, but there is a lot of constraint. Subjected to the mileage must be, more mileage is required, and then comfortness and lot of features or safety features. Something like if you are adding more and more constraint, then the cost of that vehicle is going to up rise. So in that means with constraint and without constraint, there is a lot of different. Both things we are going to minimize. That is one aspect. But unconstrained case, we will see, and constrained also you can see. Suppose generation power plant, you can consider thermal power plant. I want to generate as a 10 megawatt power, with objective is to minimize the cost. In that case, what we'll do, there is a without constraints directly, which generating unit will generate the cheaper power, then we'll allocate more generation to that unit. Let assume that the generating plants are in different locations, load may be in different location. We don't consider any other parameters like losses and all these things. Then some generators is near to the coal, the cost of the generation may be less. Then you can assign more power to that particular generator, so that generating cost is going to be less. But some, if you add some constraint, if the generating unit may be near to coal, but load center is very far away, then the losses is going to be high. In that case, the optimal allocation we need to use to assign the generation to particular generator. So in that way, by considering the constraints, you will get a lot of different in the objective value. And that's what we'll see in this unconstrained and constrained optimal problem. Another one is introduction to intelligent system. So now, whereas conventional systems are there, some of the methods are conventional methods. We'll briefly will highlight that points, but our intention is all evolutionary algorithms in intelligent systems. We'll discuss the some introduction to intelligent system in that soft computing techniques. This is what another name for this evolutionary algorithms. We also called as a soft computing techniques. Means there is a hard computing technique is there and soft computing techniques also is there. We need to compare these two. We can say that conventional computation versus swarm computing are also called as a soft computing techniques. That we will discuss one point, and the classification of meta heuristic techniques. That is what earlier there is a conventional classification as I mentioned in the first line. Here you can see that classification of optimization problems. After that, there is a meta heuristic techniques also present in this classification. What are the meta heuristic techniques like genetic algorithm, PSOs, DE, and Cuckoo search algorithm, then ABC algorithm, like that harmony search algorithm. Many more algorithms are there, but as per our syllabus, I mentioned only three algorithms to understand. Once if we are able to solve the problem using that algorithms, we can able to develop any kind of algorithm or hybrid algorithms also to solve our applications in power engineering. So now in that single solution based and then population based algorithms, mm, then is a properties of SWAM intelligence techniques. So these are all whatever we mention here in the topics. The first unit is a fundamental about the soft computing techniques. So once if we are able to complete this, and then the remaining three units are very simple. Genetic algorithm, PSO, another one is a DE. These are the differential evaluation algorithm techniques. So these is um, three algorithms. Now, once if we are aware of these three units, then we'll move on to last unit that by applying these methods, you need to solve your optimization problem. So that is all about the fourth unit. So this is the brief introduction. Now you can see the second unit. What are the topics? There is a basic algorithm here, what we call it as a genetic algorithm. This something old algorithm, but it is a base for all other algorithms also. Introduction to GA, encoding, fitness, basic operations like selection, crossover, mutation. These are the three operations we are going to do in genetic algorithm. Selection, crossover, mutation. So we need to do this three operations to get our optimal solution or to minimize the function or to maximize the function. Depends on our application, will select objective function. Suppose I want to minimize the cost, then minimization problem, or I want to improve the stability, or that we call it as a maximization problem, or profit case, to maximize the function to get more profit, like that. So it depends on the problem. You can select whether it is a minimization or a maximization. So these are the three operators: selection, crossover, mutation, and then different types of crossover. So in a crossover, we have different scenarios. So, while we are explaining that, we can able to understand there is singular, multi-layer, something like that. We have a different kind of crossovers and mutation operations that also we'll discuss in that genetic algorithm concept. Control parameter estimations. There is another method. There is a uh, nicking method. This method also used to find the optimization problem, and then parallel GA and genetic algorithm versus conventional optimization techniques. So because genetic algorithm is a heuristic techniques, or you can say that soft computing. but conventional methods are there in the odd computing technique. These two we are going to compare and detailed working of genetic algorithm with example. So now we'll take one small example like a test function. In that test function, we are going to solve the problem, optimization problem. Suppose some test function may be x1 square plus x2 square plus 3x2 plus 4. Let us assume that that is a function. Now the question is subjected to constraint x1 is less than 10 or x2 is greater than 10 or something, or between 10 or minus 5 to plus 5 or any variable in that matter. That is the constraint. To meet that constraint, we need to optimize the problem, or we need to find the x1, x2 variables using this. That's what we are going to solve the problem using genetic algorithm. So you will take as one example of a test function. You apply this genetic algorithm. Like three operations are there: selection, crossover, and mutation, and find the objective function value. This is the unit 2. When we go for unit 5, there the electrical application we have to apply the genetic algorithm. Similarly, for another algorithm like that. And unit 3 you can see that modified particle spam optimization. Normally there is a spam optimization algorithm review of basic practical spam particle spam optimization that we call it as a PSO. So we considered here as a modified PSO. That is the reason, or MPSO. Before going to modified PSO, we should know what are the basic phenomena, and starting development of PSO we will see first. Then we'll move on to different kind of particle spam optimization. In that background of PSO, variations of PSO and discrete PSO, and another one is a construction factor approach. There is a another CFA, or you can say that CPSO also we call it as. So how the variables are going to set using this equation. Normally in the PSO there is some random parameter variables are there. They mention the values are maybe 2 or something, consecutive factor C1, C2 value. But later on the research they find instead of using directly fixed value, we can go for as a this approach, CFA approach, then the performance is going to be further better. That's what they concluded as per the research literature. Similarly, hybrid PSO. So what is the hybrid PSO? You can able to mix this algorithm, PSO algorithm, with any other kind of algorithm based on their parameters. Suppose if we say cuckoo search algorithm is there, you can mix the cuckoo search algorithm with something PSO algorithm. That I call it as a hybrid PSO algorithm. Or you can mix with this PSO with genetic algorithm. Then also I call it as hybrid PSO algorithm. If any algorithms are going to mix, how we can mix, like as you're aware that something like MOSFET, BGT. We have individual, what you call it as devices. They have their own drawbacks. In the BJT we have drawback. MOSFET also we have drawback. Of course, there is different advantages also as well. But the thing is, while we are fabricating IGBT, insulated gate bipolar transistor, what we make use of the advantage of BJT, advantage of MOSFET, they club together, they form as a IGBT. Same manner, I can see this when we are doing as hybridization. What we look into that, what are the advantages are there in PSO, and similarly some other algorithm like a GA. We can mix the two things. We'll make use of another algorithm that I call it as a hybrid algorithm, or also called as, in this case, hybrid PSO. And then adaptive PSO, that is APSO, and then evaluationary PSO, that we call it as a EPSO. So there is a different kind of algorithms are there. We are going to use these algorithms using different applications. So now what we can able to do in your research, or we are going to do as a mini project and all, there is a the thing is evolutionary. I mean, what you can take it is one problem you take and then solve these problem with PSO, and then APSO and CPSO and EPSO, or CFPSO and EPSO. You solve these same problem with the different approaches, then you can able to conclude which algorithm is going to be, or which approach is going to be better. That is one aspect. Same problem you can do with some other algorithms also, and you can compare with literature. So such kind of things is nothing but your project work, nothing more than that. And research areas and applications and detailed work of PSO with an example. Now, as I said, now PSO algorithm, same problem you take it like any of the test function in GA, and same test function you take it here and to solve PSO algorithm. So these are the third unit syllabus, and we'll move on to fourth unit, differential evaluationary algorithm, differential evaluation. That means DE. This is also famous algorithm, and it is more or less similar to that of GE only. We'll see that what is the different, what is the GE algorithm will do, in GA, genetic algorithm, and what is DE will do. We'll compare these two also. And here, differential evaluation fundamentals and initial population, mutation, recombination. Whereas there, in the case of, you can notice here, in the second unit, the genetic algorithm, selection, crossover, mutation. So here you can see here population, then mutation, and recombination to create new vectors. So here we are going to apply recombination process also. That is one of the evolutionary algorithm. And then selection, and then overall D, that is selection process, new vector, selection process, and overall differential evaluation algorithm. Key operators for DE, encoding, mutation, crossover, and detailed working of DE with an example. So now what we can do is, with an example, we are going to solve this problem. That is only the fourth unit. Now there is a fifth unit, or important unit. What we can do in this applications to power systems. Whatever algorithms we discussed in the previous three units, means second, third, and fourth unit, we are going to apply that algorithms to solve this applications. What are the applications I mentioned? Problem formation of economic dispatch. Now the question may ask like this: the apply genetic algorithm, or you can say that solve the economic load dispatch problem using genetic algorithm and using PSO and using D, like that. So what we can do is economic load dispatch with D, or economic load dispatch with PSO, or genetic algorithm, like that. Another one question. And other one you can see load frequency control, LFC control, using genetic algorithm, or LFC control using PSO, or LFC control using DE, like that. So implementation of economic load dispatch, and these are the topics. Now there is a 6 questions in this fifth unit. It is fixed questions. What we can do is, you have to do economic load dispatch with GA, PSO, DE, 3 questions, and load frequency control using a genetic algorithm, PSO, and DE, like that. So these are the total syllabus. It is very simple, like what we seen in the machine learning. There is all algorithms, different units. Same manner we have here. What we did in the machine learning case, there is a algorithms like supervised algorithms or unsupervised algorithm that we are going to apply into different data sets, and we solve the problem. The mechanism I explained, then you can apply Python programming, and using any of existing data set, we can able to solve that problem. So same manner, what we did is here, we are going to solve this problem using what you call it as a genetic algorithm and PSO and DE. There we used for supervised learning or and unsupervised learning, like that. So this is about syllabus. Now we come to the first unit. As I mentioned, fundamentals in the first unit. Introduction. As per the syllabus, classifications of optimization problem. We'll see today only introduction part. After that, we are going to solve the classifications of optimization. We'll see the some classifications of optimization problem. Another one is a constrained and unconstrained optimization problem. The next one is soft computing techniques. As we discussed, different techniques we are going to apply. In that, there is a soft computing techniques. Also, we need to see the introduction part. Another one, there is a comparison, or I can say that conventional computing versus SWAM computing. So these are the different aspects, all theory orientation, the first unit. Then classification of meta heuristic techniques. As in the second topic, as I mentioned, classifications of optimization problem. Similarly, here classifications of meta heuristic techniques. Then single solution based and then population based algorithms we are going to do. And finally, properties of spam intelligent system. So these are the some topics we are going to cover in the first unit. So as I mentioned in the syllabus also, there is a what you call it as definitions and all, what is soft computing, all these things we'll see. And after that, we'll move on to one by one, and we can able to observe what are the topics need to cover. So now we'll see what is this soft computing. This term was proposed, means soft computing was proposed by the inventor of fuzzy logic. So his the name is a Jeda. He describes the soft computing definition. It is a collection of methodologies that aim to exploit the tolerance for impression and uncertainty to achieve tractability, robustness, and low solution cost. This is the point we need to consider. There is a low solution cost is important in this, and it is a principal constraints are fuzzy logic, neurocomputing, and probabilistic reasoning. The role, what this in turn is like a human mind. The role model for soft computing is the human mind. How human is going to think same way these algorithms. That's what meta heuristic techniques and all, like a natural inspired algorithms. These are all. So how the cuckoo is going to behave, same thing they developed as a one algorithm, like harmony. So how the waves is going to be generated in harmony and all, that is also one algorithm. And water flow algorithm. Like that, how the bees are going to fly randomly and then honeybees and all. So that is one of the algorithm. Like that, we have different kinds of ant lines will be there, ant colony algorithms. So like that, all natural inspired algorithms are going to apply for our electrical engineering problem. Not only electrical, all engineering problems nowadays, we are going to use this kind of algorithms. So now this soft computing is the human mind. So like that, it is going to be solved. Now we can observe here, there is a function like computing. What you are going to compute y with respect to some function. So y is equal to f of x. That is a control action. There is a variable f of x consisting of some variables in x. We need to find that variables by applying this kind of algorithms. So that's what this is the basic of computing antecedent like input we are giving, then we are applying the algorithm, that is the control action, the control parameters we have to find, or optimal parameters we have to find, then consequent. So what it will give the result, that is only the consequent. Now y is equal to f of x is a normal function, f is a mapping function, or also called as a formula, that we call it as a equation, or you can say that formula, or a algorithm to solve the problem. So now whatever problem here, the problem may be test function means we can use x1 square plus x2 square plus and so on so forth. Suppose same we are going to apply our what you call it as economic load dispatch problem, or maybe some cost function in a power system, AIPGI square plus BIPGI plus CI, like that we are using the function. Instead of f of x, it may be or something loss function, or something index, any R voltage deviations, something, any power system objective function we can use to find the solution. So that is only the thing here for the basic of computing. Important characteristics of computing should provide precise solution. These are the some characteristics. Solution must be precise, and control actions should be unambiguous and accurate. That you should not be as ambiguity whether you are to do this way or that way, or which solution you need to pick up, which control parameter you need to vary. All these things should not be ambiguity while you are selecting the problem. That's what control action should be unambiguous and accurate. These are the some characteristics, important characteristics. The easy to model mathematically. The problem is always like as I said in the machine learning and all, based on the training data, the model is going to be developed. That is mathematical model is going to be developed. So similarly here the problem which is easy to model mathematically. These are the some of the characteristics. Now we'll see hard computing. Like as I said, there is here two things, soft computing as well as the hard computing. We'll see the hard computing, then we'll move on to soft, then we'll compare these two. There is a term, hard computing is invented in 1996, L.A. Jade. According to him, the computing as hard computing if precise results is guaranteed. There is a difference in soft computing and hard computing. There is a results is guaranteed in hard computing, but whereas in the soft computing there is a some fuzziness. So anyhow, that will come. At moment, hard computing means results guarantee, and control action is unambiguous, and control action is formally defined, that is with mathematical model or algorithm. We need to apply this algorithm to this any algorithm, even conventional methods also. A lot of algorithms are there. You can able to use that algorithm so to solve the problem. And examples, you can see that numerical problems, roots of polynomial, integration. These are all some examples of hard computing. Searching and sorting techniques, computational geometry problem. Example, shortest tour in a graph. Suppose there is a geographical lane, we need to visit let 4 places. Let us assume that. Normally, if you need to cover all 4 places at once, but while you are moving, suppose let consider Ocean Park is one of the area. Let us assume that, and somewhere else. Maybe Tank Bund is another area like that. If you may have 4 or 5, and you go to Tank Bund and come back to Ocean Park and again go to some other temple near to the Tank Bund, this will take as a time as well as the distance is more. So now you have to identify shortest path. You must go first to this Ocean Park and then move further. And that is the way we have to identify searching in the better way geographically. These are the some examples. And characteristics of soft computing. It does not require any mathematical modeling of the problem solving. Whereas in the hard computing, we required that. But whereas here, we don't require any mathematical modeling of the problem solving. It may not yield to precise solution, and algorithms are adaptive. That means adjust to the change of dynamic environment. Now any parameter is going to change automatically, other parameters also going to vary, and use some biological inspired methodologies such as genetic evaluation and behavior, particle swarm, human neurons, like neuron. So how the human neuron will work, same thing we can develop the algorithm like that. We may have some kind of algorithm. Now you can see here, odd when you are writing, letters, human will write their own handwritten. That has to be, it has to be recognized by the system. So that is only the point here. We need to identify that letter using this artificial neural network. Similarly, example soft computing, what we can do, different banks are there. I need to allocate the money based on the profit, which bank will return more profit. With that analysis, the soft computing will do that process. And finally, it will decide the bank which maximize the returns. So like that, this also one of the algorithm we can do for soft computing techniques. And now the how it is going to be work, soft computing, like many examples I will tell you. One thing is how the student learned from his teacher. There is a student and teacher interaction, and in a class, how the student is going to learn from the teacher. That's what we'll do. Teacher asks the questions and also tell the answers to them. What will happen? Suppose if I ask one question, if you are unable to recall or you don't know the answer, if the teacher is teach or explain that concept, you will understand what is going to be so and so. After that, what we can another way, the teacher puts the questions and he will not answer. I will not give the answer, but he will give the hint, and he can able to recollect and ask whether the answer are correct or not. So now once if you give the hint, teacher will give the hint, then student can able to answer that. Then after that, he will explain you whether the answer is correct or wrong, like that. Then student the learn a topic and store in his memory. So this is another way, the remembering concept. So based on the knowledge, he solves new problem. Now by above these points, he will learn something. After that, what he will do is he will take as any problem and is going to solve by his own. That way, the student is going to learn the concept or is learned from the teacher. That human brain also will work. So we will observe and we'll see or we'll watch something, and we are able to learn from that, and how the others are behaving or how others are doing the things. That kind of thing, the what you can do is, a student or a human will learn continuously. That is a feedback in nature and will develop. So based on the concept, artificial neural network used to solve the problem. And other one, how world select the best. It start with population randomly and reproduce the another population in the next generation, rank the population and select the supervisor individuals. And genetic algorithm is based on the neural phenomena. The population is synchronous to solutions. Select the superior solution in synonyms. That's what the population is a synonym to the solutions. Sometimes we call it as a population, sometimes we call it as a solution. That is also one of the thing. The superior solution is synonyms to exploring the optimal solution. And another example, I can say how a doctor treats his patients. The patients, how the doctor is going to, because once the patient come to hospital, doctor directly will not give any medicine. So what he will do, doctor asks the patients about the suffering, what are the problems he is facing. He will ask, then the reply to doctor, they will give some answers, and doctor find the symptoms of diseases. So based on the symptoms, then doctor prescribed the whether he will go for another medication like tests and all, or he will give directly after observation his diseases and all the things he can able to write directly medicines. This is exactly the way fuzzy logic works. So now whatever symptoms are there, he will he will compare. Okay, this is the weightage of this type of disease, or this may be this weightage to the another disease. Like he will identify whatever the maximum possibility, he will treat first, and if not, he will go to another way. That is what the doctor prescribed the tests or medicine in Basili. And there is hard computing versus soft computing in comparison. You can see here what will happen if you compare this way. We observed already hard computing and soft computing. In that manner, it requires a precisely stated analytical model and often a lot of computation time. So all the hard computing, huge computational requirement will be there. It is imprecious uncertainty. Another one is a partial truth and approximation. So whereas in the soft computing, like a fuzziness, there is some approximation is taking into place, and direct results will come into the picture in the hard computing, whereas soft computing like approximation we need to consider. It is based on the binary logic and crisp system. What crisp will say yes or no, or true or false, or 0 and 1. Suppose there is an interview, some somebody came for an interview, and after that, crisp means whether he is going to select or not. They will close the issue. Means he want 5 members. Directly will take 5 member. Yes or no means you can reject directly or you can take it into the consideration. But whereas fuzzy logic or neural nets, what we'll do, we will not reject completely, we will give the probability or weightage. So suppose computing will decide, will give the merit order. Thus is the first person, second person, third person, like that. 100 members came for interview, and they will give 100 rankings. And we may be required 5 people. Based on the weightage, you can pick up top 5 members, you can pick up. But whereas hard computing, they don't give later point of time. You may need sixth person also. You will not conduct once again interview, and you will make use of the past data. Top 5 is over. Next sixth guy you can able to pick up. Or if in between 2 members are not reported to join, and you can go for next level, next ranking, like that. That is that one. But whereas crisp mean, they don't give that much ranking. 100 members came, they want 5 members, they will pick up 5. That's it. So they don't give weightage. What weightage here? The maybe for this job we may be suit some 80 percentage, it may be 20 percentage, maybe 30 percentage, like that. But whereas the hard computing, or you can say that crisp, whether he will fit or not, they will decide directly, yes or no. That's it. So this is the different. Now you can see some more points also mentioned, just for comparison purpose. It is deterministic. It is whereas in the soft case, it is incorporate statistically. It requires exact input data. It can deal with ambiguous and noisy data also. What is noisy data in terms of all? We discussed a lot of mixed data, redundant data, and less weightage data. These things we can call it as a noisy data. It is strictly sequential. It allows parallel computations also. It produces the precise answers, whereas in the soft computing, it can yield approximate answers. That's what I mentioned. The hard computing directly will give the solution, but whereas soft computing, it will give some approximation. So these are about introduction of this thing. Now, what we'll do, I can see another hybrid computation. As I mentioned, individually, it is a combination of conventional hard computing and then emerging soft computing. That we can say hybrid computation, or some algorithms also you can mix it. That also we call it as a hybrid computing, mixing the two things. So whatever are advantages of hard computing and advantages of soft computing will mix together. That we call it as a hybrid computing. So like that, we can see this kind of introduction. Now, later point of time, we'll see the classifications and all we'll see in the next class. And if you have any doubt, you ask me. And one more thing is, there is another what you call it as something mini project is there. I think I'm the in charge for that. And what is your proposal when you will come to college to do that? Anybody? Hello?
I think Saturday, sir.
Okay, Saturday, I think any other schedule is there?
No, any schedule is not there, but we have labs also. Every Saturday,
Saturday, but he mentioned Saturday is free. We cannot use lab slots, we need to use there. Lab already,
yes,
DSA lab already mentioned, and another one. Only one lab you have? Two labs, no? Power system
two
computational lab,
computation.
PSC. Where is that lab? PSA lab is one lab. Yeah, Friday afternoon they mentioned. Okay, so the mini project as per the schedule they mention as Thursday, isn't it?
Yes,
Now what you will do is first, as per the seniority, you just select guides. Those who want to do project in any specific area, you approach to the guides and get the confirmation from that, from the supervisors. Then you need to submit the abstract or title. Initially, you try to submit the title, then you do the literature and try to submit some abstract, like that. The end of the semester, we need to submit the report as well as the presentation. So this is the mini project scenario. Anyhow, if you come on Saturday, I will explain the total, flow of mini project. Okay, you meet me on Saturday. Is it fine now?
Okay, sir.
Yes, sir.
Okay,
Yes, sir. Fine.
yeah. So I will explain what to do for the mini project.
Okay, sir.
Okay, then you can leave now.